Okay, this recording is going to be about atomic number, mass number, and how to calculate protons, electrons, and neutrons for an atom. This is going to be on page 68 of your notes. So far you've talked about the discovery of the atom. Well, this lecture is going to be about, well, how do we distinguish different atoms from each other based off of the periodic table and the numbers on the periodic table. Okay, so every atom is going to have protons, neutrons in the nucleus, which is going to be where most of the mass of the atom is. And then we're going to have electrons orbiting the nucleus. The electrons are really small in comparison to already small protons and neutrons. Therefore, they don't contribute any mass to the atom, okay? So when we're talking about mass, we're only going to be talking about what's inside of that nucleus, and that is the protons and the neutrons, okay? All atoms of the same atom are going to have the same number of protons, okay? So if I'm talking about carbon having 6 protons, carbon will always have 6 protons. If I'm talking about an atom that has 5 protons, I'm no longer talking about carbon. I'm talking about boron, or B, okay? If I'm talking about an element that has 7 protons, I'm talking about nitrogen, or N, okay? So carbon specifically only has 6 protons, okay? So when I'm talking about protons and how many each atom has, it's specific to that atom and it does not change, okay? So we can define an atom through its number of protons through this thing called the atomic number, okay? And the atomic number is very clear on the periodic table, okay? So if I was to look at this periodic table, you see that on this periodic table, the atomic number is above the symbol, okay? So in this case, if we're talking about Mercury, Mercury's atomic number is 80, which means Mercury has 80 protons inside of its nucleus, and that will never ever change, okay? The atomic number defines the element we're talking about. So my example that I was giving you before, carbon has an atomic number of 6, which means it has 6 protons, which defines that carbon, which defines that whenever something has 6 protons, that means that it is carbon, okay? So that's what the atomic number is. So let's do a couple of quick examples. So if I was to do hydrogen, so if I look on my periodic table, hydrogen, the 1 above the hydrogen indicates that that's its atomic number, which means that it has 1 proton inside of its nucleus. Helium has a 2 above it, which means that its atomic number is 2, which means that it has 2 protons inside of its nucleus. Carbon, I've already talked about multiple times. Its atomic number is 6. Gold, which is Au, its atomic, you can't even see that. I'm pointing to it, but you can't see it. So gold has 79 above it. That's its atomic number, which means that there's 79 protons inside of its nucleus, where uranium, which is down here, has a 92 above it, which is its atomic number, which means that it has 92 protons inside of its nucleus. Okay, that's great. That's the atomic number. That is very important that you understand, no matter what atom I'm talking about, its protons will never change. Okay, neutrons can change, electrons can change, protons cannot. Okay, so let's talk about the mass number. If the center of the atom is its nucleus, where all the mass is at, okay, and if we only have 2 things inside of the nucleus that make up the mass of the atom, those 2 things are going to give us the mass number of the atom. Now this is a little bit different because this is not the mass that's on the periodic table. We'll talk about that in a different lecture. That's called the average atomic mass, okay, and that deals with these things called isotopes. However, the mass number is specific to a specific atom of something, okay? So the protons will never change, but the neutrons might, okay? So mass number, or Mn, is going to be equal to the number of protons plus the number of neutrons. Why? Because all of our mass is inside of the nucleus, and that's where the protons and the neutrons lie, okay? Or I could rearrange this equation to solve for neutrons by doing number of neutrons is going to be equal to the mass number minus the protons. Okay, so let's look at some examples for symbol notation. So if I was to name something, I would write gold with its mass number. Okay, so if I was to look at a generic example of this, it would be element with its mass number. Excuse me. Okay, that's if I was to name something. Why don't I have to put the number of protons? Well, because I could ultimately look on the periodic table, find gold, and realize that gold has 79 protons. Okay? Now, if I wanted to write a symbol for something, I'm going to put its symbol, so gold symbol is AU, with its mass number on the top, and the number of protons underneath. Okay? And then ultimately, if I wanted to, I could calculate how many neutrons this atom of gold has. So I would say the number of neutrons is equal to the mass number minus the number of protons, which is going to be equal to 197 minus 79. It's early, so I'm going to do this in my calculator. And I get 118. So this symbol, or this element of gold, has 118 neutrons inside of its nucleus. Okay? So let's look at some more examples before you do some practice on your own. Okay, so let's look at the first example here. So hydrogen 1. Hydrogen 1 is telling me that the mass of this hydrogen is 1. Okay? Now, with that being said, if its mass is 1 and its protons are 1, I can assume that there are no neutrons inside of this nucleus. Okay? And this is typically how we see hydrogen, is just hydrogen with 1 proton. So the symbol here is going to be hydrogen 1, its mass, and 1 at the bottom, which indicates that there's 1 proton. Okay? So the atomic number then defines this hydrogen, and hydrogen, if I was to look at my periodic table, has an atomic number of 1, which also indicates that their protons is 1, and the number of neutrons is going to be 0, right? Because my mass is 1, which indicates that the proton makes up all of the mass of this hydrogen atom. So then the mass is 1. Okay, number of electrons. I haven't talked about that yet. In a neutral atom, the protons are going to be equal to the electrons. Why? Because protons are positively charged, electrons are negatively charged, and if they're equal to each other, they're going to cancel, right? So in this case, we're just going to assume that all of these atoms are neutral. So with that being said, if I have 1 positively charged proton, that means that I have to have 1 negatively charged electron to get a neutral atom, okay? And if you remember, neutrons have no charge. Okay, they just contribute to mass. Okay, let's do one more example, and then I'll let you fill in the rest of these guys. The next one is carbon with a mass number of 12 and its atomic number of 6. Okay, so let's start with a name. So to name this, I'm going to say carbon 12, right, because that's its mass. Its atomic number is 6, and I can verify by looking at the periodic table. Since atomic number defines the number of protons, that means it's going to have 6 protons. To solve for neutrons, I'm going to say mass number minus protons, which is going to be 6. Its mass number is 12, and in a neutral species of atom, or carbon, I'm going to have the same number of electrons as protons. Therefore, I will have 6 electrons. Okay? If you watched this video, I want you to put on a piece of paper atomic number equals the number of protons and hand it to me at the beginning of class. Thank you.